This video tutorial is on accuracy versus precision. So these are very similar concepts, but they do have their slight differences. So let's start off looking at accuracy. Accuracy is how close a measured value is to the actual or true value. So what that means, if we're looking at a target, our actual or true value, what we're aiming for, is the bullseye. So accuracy measures how close your arrows or whatever you're shooting at the bullseye is to the center. So however close you are, that's how accurate you are. Now precision is slightly different. Precision is how close the measured values are to each other. In this situation, it doesn't necessarily matter how close the marks are to the bullseye. It just matters how close they are to each other. For example, if we look at these three images right here that I have labeled for you, our first one, our 5 marks right here are all exceptionally close to each other, but they're not very close to the bullseye. What that means, because they are close to each other, they are precise. They're not accurate because they're not close to the bullseye, but they are precise. If we look at our second target, each of these 5 marks are relatively close to the target, right? I mean, they're relatively close to the bullseye, but they're pretty far from each other. They're not right next to each other. That means that this would be an accurate sampling, but not precise because they're not very close to each other. Our last target here is accurate and precise. The reason it's accurate and precise is because the markings are close to each other, but they're also all right on the bullseye or the actual true value. So this would be accurate and precise. It of course can be both. So those are 3 examples of accuracy versus precision. Accuracy and precision are also used when looking at data, which we're going to do a lot in chemistry, so we have to know how to use it with data. Let's read through our practice problem here. So Stephen has a block of iron that has a mass of exactly 1.5 grams. So we're going to want to remember that. This block has a mass of exactly 1.5 grams. He gives that block to 2 groups to measure. After looking at the data, we need to decide which group measured the block accurately and which group measured the block precisely. So let's start with group A. Trial 1, they got 1.99 grams. That is nowhere near the true value. 1.96 grams. Again, nowhere near the true value. And trial 3, 1.93 grams. Again, nowhere near the true value. But as we look at our 3 different values here, 1.99 through 1.93, they are all quite close to each other, right? There's only a total difference of 0.6. So those are pretty precise measurements. So this first group, group A, would be considered precise but not accurate. The reason it is precise but not accurate is because they're close to each other, but they're very far from this true value. We know the block has a mass of 1.5 grams, but over here, they measure it, they're all close to each other, but they're not close to 1.5 grams. So that is precise but not accurate. Group B, 1.51 grams, 1.65 grams, and 1.45 grams. So these are a little bit more spread out because we have 1.45 and 1.65. That's a difference of 0.20. Sorry, this one over here should have been 0.06, not just 0.6, 0.06. 0.20, so that's much more spread out than this group over here. So these aren't very precise. But our block had a mass of 1.5 grams, which would make group B accurate but not precise. So group A would be precise and group B would be accurate because these are close to the true value and these are all close to each other but not to the true value. Okay, what I want you to do now, pause the video and attempt these. There's 5 practice problems here, 4 targets and 1 word problem with data. Attempt these 5 practice problems on your own, then come check back with the video. Okay, you should have paused. You're just labeling each one accurate, precise, neither, or both. So let's look at this first one. This, I crossed out the answers very well. I know. I'm going to reveal them now. It's going to be very exciting. Our first one, we have our everything is close together. This one is going to be high accuracy and high precision. So this answer would be both because they're close to the target. They're also very close together. This one, I'm going to guess this one is precise, high precision, but low accuracy. Oh, look at that. It's like magic. Okay, this one right here, let's go to the reveal. High accuracy, low precision. Close to the target, but not close to each other. This one's looking to me like neither. They're not close to each other and they're not close to the target. And there we go. That would be neither low accuracy and low precision. Okay, down here on the bottom, the block that Marcus is given has a mass of exactly 21.44 grams. Let's look at these two groups. We have 21.49, 21.51, and 21.36. Over here, we have 21.33, 21.36, and 21.44. Now this is a little bit more difficult because both of them are pretty close, but also pretty precise. So what we would go with here for both of these is a little bit of a trick question. Both of them are going to be accurate, and neither one is going to be very precise because there's a big difference between them. If you were going to do a precise one, Group B would be more precise than Group A because the measurements are closer together, but both groups are fairly accurate. So that is a little bit of a trick question for you there, but if you were going to choose one, I would have chosen this one is accurate and this one is precise, but both are actually fairly accurate. So that is accuracy versus precision. We'll work a little bit more with that, and until then, goodbye and farewell.